Hi everyone, my name is Makumba Gerard of EduMath. Now in this video, we are going to look at the introduction to errors and the approximation. Here we are going to see the terminologies and how we use these terminologies in navigating through the calculations. But hey, if you are new here at EduMath, consider subscribing and hitting the notification bell such that you can be notified of our new videos that we make every day and upload. So let us get started and see you there. Errors and approximations. An error is a deviation from the exact value. That's what we call an error. So what does it mean? It implies that error, small e, is equal to exact value minus approximate value. So our formula in the box because it is very important. So we are going to have an example to demonstrate an error. If the exact value x is equal to 2.521 and the approximate value x prime is equal to 2.52, we are going to use this example in the illustration of the terms that are going to follow. Alright, so let us start with calculating the error itself here. So error E is equal to x minus x prime. So this is equal to 2.521 minus the approximate value, which is 2.52. So the error here is equal to 0.001. Alright, so we have seen how we can be able to get the error between two values, the exact and the approximate value. Next, we are going to look at the absolute error. Absolute error is the magnitude or modulus of the error, i.e., so we have the magnitude or the modulus of this error here. So this is equal to the magnitude of x minus x prime. Okay. So for this reason, the absolute error is now equal to the magnitude of, we bring this here. This is 2.521 minus 2.52. So our absolute error is equal to 0.001. Absolute, these magnitude signs only ensure that the value you get should be a positive one. Next, we are going to look at the relative error. Next terminology there is the relative error. This is the ratio of absolute error to exact value. So in reference to the example which we are having, we are saying that relative error, this is equal to the absolute error divided by the exact value. Now in reference to what we have, this here is equal to, we have got the absolute error as 0.001. So I'm going to just substitute 0.001 divided by the exact value, which is 2.521. So we shall have to put here 2.521. So when you compute on our calculators here, it's going to be 0.0003997. This is when rounded off to 3 significant figures. So that is our relative error in the two values. Next terminology is the percentage relative error. Percentage, someone can be guessing what it is. This is the relative error expressed as a percentage. That is to say, percentage relative error is equal to relative error times 100. But what is relative error? Relative error is the ratio of absolute error to exact value, this here. So I'm gonna substitute it for this. Now times 100. So this here is the percentage relative error. So can we get it in reference to the question? Yes, we know that absolute error, relative error is here, which is this value here. So I'm going to get this value, substitute it for this, and we get the percentage relative error. So that is to say, percentage relative error is now equal to 0.000397 times 100. So this gives me 0.0397%. So this here is the percentage relative error. Alright. The next terminology is the tolerance error. Tolerance error is the maximum possible error in any given value, i.e. tolerance error, which we shall be just shortening as TOL. This is equal to a half times 10 power negative n, where n is the number of decimal places. Now, this tolerance error is very important when it comes to finding the roots of equations here in numerical methods. So, tolerance error occurs within one value. It occurs within one value. So take an example, e.g. if our exact, I'm going to still refer to our example which is right here. I'm going to take this. So if x is 2.5 to 1, then we need to compute the tolerance error for this. This is going to be a half times 10 power. How many decimal places are here? 1, 2, 3. So this is to power negative 3. So our total here is 0.0005. Can be written in this or this form. Now we can base on the tolerance error to get the maximum and the minimum values of a given value. Take an example of still this very number here. Next we are going to look at the maximum and minimum values. So if our exact value x is 2.5 to 1, then the maximum value of x is going to be equal to this exact value plus the TOL, or the tolerance error. So this is going to be x plus TOL. So this gives us 2.5 to 1 plus our tolerance, which is 0.0005. And the maximum value there becomes 2.5 to 1.5. So this here is the maximum value of this. We can as well get the minimum value of x. Minimum value of x is going to be x minus the TOL, the tolerance error. So this is going to be 2.5 to 1 minus the tolerance error, which is 0.0005. Okay. So when we subtract on our machines, we shall be getting 2.5205. So this here is the maximum value and this here is the minimum value. From here we can be able to get the range within which the value lies, or limits. Range or limits of accuracy. Now, having got the maximum and the minimum values, limits and range are two different words, but the concept is the same. Limits are values that restrict the region beyond which the exact value of the function cannot lie. So the degree of accuracy oscillates between the minimum and the maximum values. Okay, so the limits become, now the limits of accuracy are here, minimum value, comma, the maximum value. Now, having got the limits of accuracy, so let's take the reference of the example given to us there. We have got the minimum value and the maximum value from here for the exact value, which was x equal to 2.521. this we have got their minimum and maximum values. So we are going to use these values here to find the limits of accuracy for a value 2.5 to 1, e.g. the limits of 2.5 to 1 is equal to, what is our minimum value? It is right here, 2.5205, comma, the maximum value is right here, 2.215. So these are the limits of this value here, that value alone. Alright, so this has been the introduction to errors and approximation. But before I leave, I want to give you two numbers to try out this knowledge here. Find the maximum possible errors in each of the following values and hence find their limits. Alright, this is what we have to go and try. Find the maximum possible error in each of the following values and hence find their limits. So you find the maximum possible error in this, find the maximum possible error in this, then go ahead and find the limits in each of these. So this is where we end, and I want to thank you very much for being part of my audience. If you are new at EduMath, consider subscribing, consider recommending the channel to your fellow mathematician such that we can all develop as mathematicians. I want to thank you very much and God bless you.